We invested in this mission for over 60 years now. To get this close to the sun, we cannot just give it up that easily. And Parker Solar Probe is ready to do that. We've seen the total solar eclipse with all this majestic structure that the solar corona displayed. Parker Solar Probe was traveling through these structures.
NASA's Parker Solar Probe has just sent back data that has left scientists stunned. For the first time in history, we are seeing the sun in a way that was never possible before. What was just discovered is changing everything we thought we knew about our star. This spacecraft is the closest human-made object ever to approach the sun's surface, venturing through extreme heat and radiation to gather data once beyond our reach. Scientists expected it to refine our understanding of solar winds, magnetic fields, and flares, but what it found was something far more unexpected, something that could completely alter our perception of the sun and its influence on the solar system. NASA has just confirmed that within the sun's corona, its outermost and most mysterious layer, there is something hidden, a secret that has puzzled scientists for decades. The probe has uncovered evidence that could rewrite our understanding of how the sun functions, how it affects space weather, and how its intense energy shapes our solar system in ways we never before imagined. Launched in 2018, the Parker Solar Probe is one of NASA's most ambitious missions, designed to fly closer to the sun than any spacecraft before it. Moving at an astonishing 430,000 miles per hour, it holds the record as the fastest human-made object in history. To put that into perspective, at that speed, one could travel from Earth to the Moon in less than an hour. But speed alone isn't the only impressive feat. The spacecraft also has to withstand temperatures exceeding 1,000,000 degrees Fahrenheit as it dives through the sun's atmosphere. It is a technological marvel, built to endure conditions that would destroy almost anything else. Its journey takes it through the sun's outer atmosphere, where temperatures soar to millions of degrees. The goal is to uncover the biggest mysteries of our star. Scientists have long questioned why the corona is much hotter than the sun's surface, how solar winds accelerate, and what drives the powerful magnetic forces that shape space weather. Understanding these processes is not just about curiosity, it's crucial to understanding the sun's impact on Earth and the solar system. The sun's energy influences life on Earth in ways we still don't fully comprehend. Solar storms, massive bursts of charged particles, can disrupt satellites, knock out power grids, and even affect climate patterns. The Parker Solar Probe is providing data that could one day help predict these storms before they reach Earth, potentially preventing catastrophic blackouts, GPS failures, and communication disruptions. As it plunged deeper into the corona, the spacecraft detected strange magnetic waves unlike anything ever observed this close to the sun. These waves weren't just disturbances, they appeared to be influencing the movement of solar material in ways that defied existing models. Even more shocking, the probe recorded invisible bursts of energy, intense surges of power that seemed to appear and disappear within fractions of a second, hinting at an energy source we had never before been able to detect. These findings could finally explain why the corona burns so much hotter than the sun's surface and how these unseen forces might be affecting not just the sun, but the entire solar system. What the probe found suggests that the Sunday may be even more unpredictable than we thought. The implications of these findings extend far beyond our understanding of the sun. They could redefine space weather predictions and our ability to safeguard Earth against solar storms. The mission was expected to confirm existing theories about solar turbulence, but instead, it uncovered energy levels far beyond what anyone predicted. Dr. Justin Casper, a lead scientist on the mission, admitted, "We expected to find turbulence, but this level of energy is beyond what we predicted." Even more surprising, the findings challenge ideas first proposed by Dr. Eugene Parker, the astrophysicist after whom the probe is named. His groundbreaking work on solar wind laid the foundation for our understanding of how charged particles stream from the sun, but these new observations suggest that the sun's corona behaves in ways we still don't fully understand. One of the most shocking discoveries is the presence of switchbacks, strange zigzag patterns in the sun's magnetic field. These sudden reversals, never seen this close to the sun before, seem to be linked to massive bursts of energy. They may be the missing piece in the puzzle of how the corona stays so hot and how solar winds accelerate across space. If confirmed, this discovery could reshape our entire understanding of how the sun's energy moves through the solar system. The implications of these findings go beyond academic curiosity. They could revolutionize solar storm predictions, allowing scientists to track and understand the hidden magnetic forces shaping these storms. More accurate predictions could help protect satellites, power grids, and communications networks from potentially devastating disruptions. For astronauts, the discovery that the sun's corona behaves in ways we didn't anticipate means that current space weather models might need a complete overhaul. Missions to the Moon, Mars, and beyond will require new shielding and forecasting techniques to keep astronauts safe from unpredictable energy bursts that could pose significant health risks. For decades, scientists have worked with models that suggest the sun follows relatively predictable cycles of activity. But the Parker Solar Probe's findings indicate that the sun's magnetic field may be far more dynamic and volatile than previously believed. If this is true, it raises an unsettling question: have we been underestimating the true power of our star? Could solar storms be more frequent and intense than we have accounted for? If the sun's energy output is even slightly more unpredictable than we believed, it could change how we prepare for space travel and how we protect our planet's technology-dependent society. The Parker Solar Probe is far from finished. It is still on course for even closer flybys, with future passes expected to bring it within just 4 million miles of the sun's surface, closer than any spacecraft in history. Each approach will allow scientists to collect even more detailed data on solar winds, magnetic fields, and high-energy phenomena that have remained a mystery for centuries. These discoveries may be just the beginning. The unexpected magnetic waves and energy bursts detected so far suggest that even greater solar mysteries could be waiting to be uncovered. Scientists are now preparing for future observations that could confirm whether the sun's corona operates under completely unknown physical mechanisms, rewriting textbooks and challenging fundamental assumptions about how stars function. Meanwhile, back on Earth, the implications of these findings are already shaping the future of space weather forecasting. NASA and other research institutions are updating their models to incorporate Parker's latest discoveries. Understanding the sun's behavior more precisely could allow for early warnings about solar storms that threaten satellites, power grids, and astronauts in deep space. The more we learn, the more urgent these questions become. Could these discoveries mean that the sun's activity is far more chaotic than we ever realized? Could an unexpected solar event pose risks to modern technology? Could an unknown mechanism within the sun trigger a space weather phenomenon unlike anything we have ever seen before? And if the Parker Solar Probe is already uncovering secrets about the sun, what will it find next as it gets even closer? With each new revelation, our understanding of the universe is being reshaped. As the Parker Solar Probe moves even deeper into the solar atmosphere, we may be on the verge of unlocking some of the most profound secrets of our solar system. One thing is certain: the mysteries of the sun are far from solved, and what comes next could be even more astonishing than what we've discovered so far.